All right, so this is for quiz 4. So we're going to start off with a little bit of solving by graphing. So first one says, what's the solution of the system of equations shown below? We've got y equals negative 2x minus 1 and y equals x plus 5. Again, you can solve this however you want. With the amount of space there, it's kind of intended to be graphed. You're more than welcome to solve it by substitution or elimination, because it is well set up to do either of those also if you wish. So what we're going to do, though, is we're just going to graph it. So we're going to throw it into Desmos, and then we will graph it. So we got y equals negative 2x plus 1, I think. Nice put down here. Negative 2x minus 1. And for the other equation, y equals x plus 5. So we solved it by graphing. We can see the answer is where those two connect. That would be at the point negative 2 comma 3. And so what we're going to do is just grab that, right like that. And that is our answer. So from the graph, we can tell it is just going to be point negative 2 comma 3. And we're all set. That's all we have to do. I'm going to do it in the TI calculator as well. So I'm going to show how to do that. But that's it. Like I said, you could do it a different way, but that's how I'm going to do it. So for this one, what was our equations again? Negative 2x minus 1, negative 2x minus 1, and then we had x plus 5. So what we're going to do is graph it. I can see where they cross, so that's good. So now that I can see where they cross, I'm going to go second, and hit the trace button for calculate. Pick number 5. I want to find out where those cross. I want to find their intersection. The blue curve, the red curve tell me the answer. And so it tells me down at the bottom there, negative 2 and then 3. So we'll grab that. And so again, we get the same answer, negative 2 for x and then 3 for y. It always goes x and then y. And that's it. So that's what we got for number 1. All right, for number 2, it says, for this system of equations, draw the axes, then graph the system. So we're going to have to graph this by hand. Circle the solution on the graph, and then write the solution as a coordinate pair. All right, so I'm not quite sure where I want to put my axes on this one yet. But I see I've got this plus 6. That tells me that this one has to start at 6. Because remember, it's y equals mx plus b. This is going to be the y-intercept. And this is going to be the slope. So I know I have to start all the way up at 6. So I somehow have to get up 6. So I'm thinking that my axes are probably going to be good down here this time. Now this could be wrong. I might need to go over here. So maybe I'll move this over into the middle. Maybe we'll try that. Again, if it doesn't look very good, we'll have to move it. To avoid all of this, I probably could just graph it in the calculator first, but I'm going to graph it by hand. So my y-intercept is 6, so I'm going to go up 6. 1, 2, 3, 4, 5, 6. And my slope is negative x. So I'm going to go down 1, and then to the right 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. I could also go up and to the left. All right, well, that looks okay. I'm hoping that I find my intersection here. So let's check out the other equation. So the reason I did this one first is because it had m and b pretty clearly in there. Again, we can always write this as plus 0, and so that's going to be the y-intercept. Down here at 0, 0, this is going to be the slope. So if my slope is 2, that means I'm going to go up 2 and then right 1. So we'll go up 2, right 1, up 2, right 1, up 2, right 1. And so we can go ahead and draw the line there. All right, so draw the axes. I did that in black. Graph the system. I did that in red, and I did that in blue because I have to do both lines to graph the system. So part B says circle the solution on the graph. So this is just realizing that the solution is where the two connect. realizing that the solution is not any of the intercepts that I would find. So I did that part. And then part C says write the solution as a coordinate pair. So if I go to this point, it's at 1, 2, 1, 2, 3, 4. So it's at the point 2, 4. And there we go. Again, you can get part C just by throwing it into your calculator as well if you want. But since we did it by hand, we actually got the answer without the calculator. You can also get that solution with elimination or substitution if that's your desire. That's it for number 2. For number 3, we have to say how many solutions we have. So for the first one, we can see that we just have one line, which means that they're overlapping. So that's the same equation. So when we have the same equation, that would be the infinitely many solutions. So that's going to be our answer for part A, is infinitely many. For part B, we can see we've got these 2 lines. Oops, sorry, I forgot to say why. It's the same line. For part B, we can see that these 2 lines are not going to touch. They're not touching. These are parallel. Since these 2 lines are parallel, since they don't touch, that means that there are no solutions. So we get no solutions for part B. Then the last one has to kind of go with the last one. So we've got one solution, and one solution is where those 2 lines intersect. So since these are intersecting, this is going to be one solution. So that's it. So that's what we get for the answers. First one is going to be infinite. Second one is no solution. Last one is one solution. I use some of the little math symbols over here just because I like the math symbols. If you want, you can write out the words. Infinitely many. Oops. For part A. For part B, there would be no solutions. And then for part C, this is the one that has one solution. So the only thing you have to write is those words as answers or the symbols if you would prefer the symbols. I like the symbols, so I would probably use the symbols. Up here, this just kind of gives you the reasoning. Same line, infinitely many. If they overlap, parallel lines never touch. That's weird parallel. There we go. Parallel lines never touch, so there's no solutions. And when they intersect like that, that gives us one solution because there's only one point where they cross. All right, for 4, from the graph, what's an approximate solution to the system of equations? So we're just kind of making a guess. So this time we don't have any equations. We just have to guess where the solution is. So again, we can kind of realize that the solution is in this box because the solution is right here where they connect. So we can make a guess. So in X, it's got to be something between 2 and 3. And then in Y, it's going to be somewhere between 3 and 4. Now, I know it's not on the line, so I definitely don't want to say that the number itself. It looks like it's kind of at about 2.5, maybe 3.5, because it does look like it's kind of in the middle of the box. So maybe my answer will be 2.5, comma 3.5. Again, that might not actually be the answer. It might be like 2.4 or something, but that looks pretty close to the middle of the box, so I'm going to go with it. There's no actual calculations on this one. This one's all about using your brain and kind of recognizing where that solution is. All right, for number 5, bowling alley A charges $12 per person and $100 reserve lanes. Bowling alley B charges $28 per person and $20 reserve lanes. Part A says graph the system. So if we graph the system, we'll start with bowling alley A. So that's $12 per person is going to be the rate, which is going to be the slope. And $100 to reserve lanes. We have to pay that at the start, so that's going to be our y-intercept. That's going to be B. So I can get an equation for that. Y equals 12x plus 100. So I may as well graph that now. So I know I've got 100. Now this is a little hard to graph because I have to go up by 12 if I go over 1. And that's kind of hard to do on this graph because it's 50. So it wouldn't make too much sense to go 1, 12, 2, 24. So I think I'm going to pick some nice easy points. So I'm going to think what happens at 10. 10 seems like a good one because then that's going to give me kind of a big difference. So if I tried 10, so 12 times 10 plus 100, not 1,000. But 12 times 10 plus 100 is going to be 220. So I can plot the point 10 to 20 seems kind of reasonable. That's kind of like right there. So if I draw a line between those, that's kind of the first one. So that's for bowling alley A. Next, I'm going to do bowling alley B. So this one charges 28 per person, and that's a rate because that's every person has to then pay that extra 28. So this is going to be the slope again. And $20 to reserve lanes, that's going to be the y-intercept. That's going to be B. So my equation for that one would be 28x plus 20. Again, it's kind of hard to graph because 20 is like down here. And then I need to get 28x. Again, I don't want to go up 1 and over 28. That doesn't seem reasonable. So I think I'm going to go all the way out to 10 again. Because 28 times 10 plus 20 is going to be 300. And I can plot 10, 300 pretty nicely on this graph. Because 300 just right there. I'll draw the line. I can keep going, but I'll just keep it there. And that'll be B. So remember, we can keep going out forever. Here we can keep going out forever too. We can't bowl less than 0 games, so that's why there's a dot at 0 is fine. All right, so that's part A. Part A is to graph it, so we graphed it. Part B, for what number of guests will the cost of bowling alley A be the same as the cost of bowling alley B? So I need to see where these two things connect. And this we can kind of tell from the graph because it looks like they connect right there at 5. So we're going to go with 5. Again, it's a number of guests, so 4 is definitely wrong. 6 is definitely wrong. We can't really have a fraction number of people, so it's got to be 5. But then for C, it says, what's the cost for that number of guests? Now, the Y, I mean, it kind of looks like 150, but again, with these numbers, it might not be 150. It might like be 155 or something. Well, not 5, because it has to be even. So we actually need to graph this, or plug in 5 for one of the answers. Just to be safe, I'm going to graph it, because I want to see if my graph actually does look like this. So let's go ahead and plug it in. So we got 12x plus 100. And then for this one, we have y equals 28x plus 20. Again, it doesn't look anything like the graph I made because my scale is way off. So if I want it to look like the graph that we have in the picture, my y needs to go from 0 to about 350. So I'm going to come down here and make my y go from about 0 to 350. And I'm even going to count by 50s like in the picture. Okay, so we can see we're counting by 50s. If I want to make it look even nicer, we can get rid of the minor grid lines and make it really look like all the 50s. For the other one, for the x, it's going from 0 to looks like about 12. And that one's counting up by 1s. So again, I can come down here. I can play with the x-axis and go from 0 to 12. And I can count by 1s. And that does look a lot like the graph that we made. So that's pretty good. Did I even get the colors right? Do we match up with the colors? Yep. So again, I can just see where those connect, and it isn't 150. So we were right to double check. So it is actually 5, 160. So kind of like we talked about in class for those word problems, these numbers have meaning. So here it's the number of people, and that's the price. So it's $160. And we'll grab that. I'm going to just make it really small since we already have the big graph right here. That was bigger than I thought it was going to be. But we get 5, 160, so we know the answer here is 160. And that also double checks the 5 too. If we wanted to be really bold, we could say, well, I know the answer is 5, so I'm just going to take the 5, and I'm going to plug the 5 in for x. So we could be really bold and say y equals 12 times 5 plus 100, y equals 60 plus 100, and y equals 160. So we could actually do this without the calculator at all. If we feel really confident with our 5 answer, which I wanted to double check, but if we feel really confident, we can just plug it in and get the answer right away. So that's it. Again, for these ones, like we said in class, you could solve it with an arithmetic sequence. You could do a table and just kind of count people and see where they would actually match up. It's your call. You can do it however you wish. But that's number 5. All right, for number 6, it says prove the solution to the system below is 5, 38 by solving using substitution. So it tells us we have to do substitution. And doing it with a graph really wouldn't help us since we already have the answer. So the graph isn't going to do anything for us. Elimination might be something else to try, but this looks like it's well set up for substitution because the y is already by itself. So we would actually be doing more work if we try to do elimination. This is actually a useful little hint. So what we do is we look to see what's alone. Right now the y is alone. Since the y is alone, we're going to take this part and plug it in for the y. So we always plug in for what's alone. Y is alone, so we're going to plug in for the what's alone. So we get 1/2 and then 8x minus 2, because we're going to plug it in for the y, minus 2x equals 9. Now from here, things are kind of nice. We can go ahead and just distribute. And now this is looking a lot like what we did in Unit 1. We're just solving a regular equation. So half of 8 is 4. Half of 2 is 1. Minus 2x equals 9. I see I have like terms on the same side, so I'm going to combine those. 4x's minus 2x's is 2x's. The minus 1 just drops down. The opposite of minus 1, I got to get it to the other side. I can do that by adding 1 because that'll cancel that to 0. So 2x equals 10. And then it's 2 times x. The opposite of multiply is going to be divide. So we get x equals 5. All right, well, that's good because that's what we want to get. So far, it seems like we got pretty good moves here. So we're going to take the 5, and what we're going to do is plug it in now for the x. Now, I could choose either equation. The reason I'm going to choose the top one is because y is already by itself. So it makes a little bit more sense to do that because it's less work. So I'm going to put 5 in for the x, minus 2, y equals 40 minus 2, y equals 38. All right, now we're almost done. We got one last thing to do, and that's to say I got the right answer. I got 5 for x. I got 38 for y. I am done. So we can just say we proved it. We got it. We got our substitution. So with that one, again, the answer is not important. The answer is already in the question. No point in giving me the answer. But it's that process of being able to do the substitution. So that's what we got for 6. For 7, it says Jill's in the middle of solving a system of equations by substitution. She's currently at this equation. So that kind of looks like what we had. So we had something that looked a little bit similar to that, right? We had this right here. Could the graph shown be what Jill is solving? So if we look at the graph, this is a graph of parallel lines. So this is a graph for no solution. So we know for no solution should be a number equals 0. And remember, that number cannot be 0. Oops, don't need a parentheses there. So any number that's not 0 equal to 0 as we're solving it would tell us that we have no solution. So let's see if that's what we get. If we get a number equals 0. So let's finish it up for her. So I think right now I'm going to do minus 3y. No, I don't want to do that first. I want to combine like terms first. So negative 3y equals 3y. 12 minus 6 is 6. All right, now I need to get the y's over to the other side. So I'm going to minus 3y on both sides. So negative 3y minus 3y is negative 6y equals negative 6. I have to divide both sides by negative 6. And I get y equals 1. Well, y equals 1 is not number equals 0. So no, it can't be. Y equals 1 means that we should have one solution. If we have one solution, the graphs should intersect. So that's my justification. Now I need the whole thing for my justification, because again, we're trying to show that we know based on the graph how many solutions we should get. So on this graph, parallel lines would be no solution. We get a number that's not 0 equal to 0. If we get y equals a number, that means we're going to get one solution. So there we go. So that one's all done. So just for reference, just to remind everybody, if we get a number equal to itself, that's when we have infinite solutions. If we get a number that is not 0 equal to 0, that's when we have no solutions. And if we get something that's a variable equals a number, I'll do it in red because that's what we got here. That should be our one solution. And what do all these graphs look like? One solution should be an intersection. No solution should be parallel. And infinite solution should be the same line. So there might be a lot to remember here, but we did pretty good in class. I'm going to say cross instead of intersect, since I used the word intersect up there, and we talked about the word cross a lot in class. So that's what we want to recognize, is that those are the three types of graphs we can get. Those are how many solutions we get for each of the graphs. And then the equation version, I guess I'm going backwards, but the equation version, then that's how we can recognize it in an equation. So this one's a little bit deceptively tricky because there's actually a lot to know about it. But like I said, we did pretty good with these in class, and we just want to link it to what our equations look like. So link it to our forms. All right, we're back. Found the typo, so that's okay. But anyway, we're going to do number 8. So number 8, it says Paula buys 3 skirts and 10 bracelets for $126. So what we want to do is come up with an equation that models our first piece of information, since we have to write the system of equations. The next day, she's going to buy 1 skirt and 5 bracelets for $50. So we're going to need a second equation to model that. So it's not too bad. We're going to call the skirts X, and the bracelets are going to be Y. Again, you can use S and B if you really want. I'm just going to stick with X and Y. I think a lot of people prefer these when we do problems like this. So for the red equation, we're going to have 3 skirts and 10 bracelets, so 3x plus 10y, and it's going to be $126. In the blue equation, we've got 1 skirt and 5 bracelets for $50. So at this point, we're done with part A. For part B, it asks how much does each skirt and each bracelet cost? So you kind of have your options. You can solve it by graphing if you want to solve it by graphing. You can solve it with substitution if you want to solve it with substitution. But this one looks like it's kind of well set up for elimination, since we have 3x and 1x. We've got 10y and 5y. So we can kind of eliminate either of the variables pretty quickly. Now there's not much space, so I'm guessing a lot of people are going to choose to solve it by graphing. But if we want, we can try and get rid of one of the variables. If we want to do kind of the mindless way, we can multiply the bottom one by -3, the top by 1. I actually think it might be a little bit easier to multiply this bottom equation by -2. The reason for that is if we check out what happens, so 3x plus 10y equals 126, the bottom equation is going to become -2x minus 10y equals -100. And when we add these up, 3x's plus -2x's is 1x. 126 plus -100 is 26. We already have the answer for x. That's already done. Since x was the number of skirts, we know it's $26. So we're already halfway done. Now we need to get the amount for a bracelet. So a bracelet is y. So I have my choice of either equation. The reason I'm going to pick the bottom equation is just because this x already looks like it's almost by itself. So 1x plus 5 times 26. Oops, that would be in the wrong spot. I guess I don't really need to pick that because I got that for, if I found x, not y. My mistake. I was still thinking about things we did in class. All right, we found x. So we've got 1 times 26 plus 5y equals 50. So I can subtract 26 from both sides. So I get 5y equals 24. If I divide both sides by 5, I'm going to get y equals, now this isn't going to come out nice. We're going to get 4.8. But that's okay, because remember, the whole context here is with money. So 4.8 is really $4.80. So that's a legal amount of money. That seems normal. So for a bracelet, it's going to be $4.80. And so that's what we get for our answer. So I already graphed it. Just to double check, if you want to double check with a graph, again, that's totally fine, or with one of the other methods. We do end up getting, if I zoom out to where it looks, oops, forgot I still got my axes. I do get 26, 4.8. Like we talked about in class, the danger is you can't just write that down as an answer because you have to say which is which. So in this case, we made skirts the first one. We made that the X, so that would be 26 for a skirt. Bracelets would be $4.80. That's where the 4.8 means. So we don't want to just say 4.8. We do want to have that meaning in context of $4.80. All right. Number 9 says use substitution to determine whether the system below has no solutions, infinitely many solutions, or one solution. So again, it says to use substitution, so we're going to use substitution. Obviously, if you want to double check it with a graph, I'm not going to stop you if you want to try and double check it with the graph. Here, the y is already by itself, so we're going to take this expression and plug it in for the y. So we're going to get 12x minus 6 parentheses 2x plus 2.5 equals 15. We're going to go ahead and distribute this negative 6. So we want to be careful because it is a negative 6. So 12x minus 12x. Negative 6 times 2 is negative 12. Negative 6 times positive 2.5 is minus 15 equals 15. So we get negative 15 equals 15 because these are going to cancel. Now right away, I can tell the answer is going to be no solutions because those two numbers, that's not true. Negative 15 does not equal regular 15. If we want to go one step further, if we want to add 15 to both sides, we get the official 0 equals 30. We get 0 equals a number that's not 0, which again leads to no solutions. So that's definitely not true. And that's it. So there we go. Again, if you want to graph it, you can graph it. We should get parallel lines if we graph it. All right. For number 10, which gives a valid reason for using the solution method to solve the system of equations shown? So we have our 2. Again, since it's set up like this, it probably looks like it's going to be elimination. We wouldn't want to graph it unless we were using Desmos, and graphing is not even a choice, so we're not even going to graph it. So between the two, the reason I want to pick elimination is because the x's and the y's are both on the same side. So nothing is by itself. Nothing is isolated. So that kind of gives me the hint that I want to use elimination. So let's go ahead and get rid of these substitutions. The reason we would pick a substitution would be if a variable was by itself. So going back to some of the other ones, this one is good for substitution because the y is already by itself. This one is good for elimination because the variables are together. This one, I guess that's not a full equation, so we'll skip that one. This one is good for substitution since the y is already by itself. If we go back to some of the other ones we did, this one you kind of have either choice. So the y is on top of the y, the x's are on top of the x's. Personally, I think probably just doing substitution, making 12x plus 100 equal 28x plus 20 will be easier. But that one's kind of a coin flip. And then if we come back here, again, we have the y by itself, the x's are kind of stacked up. Again, that's kind of a coin flip. Same deal here when the y's are like that, kind of a coin flip, but this is really the graphing idea if you just have them both y equals. Anyway, that's why we would pick elimination instead of substitution here. So now we have to look at the reasons. So the reason for this one says a coefficient in equation 1 is an integer multiple of a coefficient in equation 2. So integer multiple would mean that the numbers in 1 are bigger than 2. So let's see if that's true. So 3 to 9 is not true. 8 to 3 is true. So that does work. So multiple does work. Now I need to think about an integer. So if I want to go from 8 to 3, or sorry, I want to go from 3 to 8, I'm trying to think, but you can't multiply an integer because 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. So this is not an integer multiple, so that doesn't work out. So we're going to pick B by process of elimination, using elimination, I guess. But a coefficient in equation 2 is an integer multiple of a coefficient in equation 1. So this says that 2 is bigger than 1. So if I look at 2, where 2 is bigger than 1, it would not be with the 8 and the 3, because 3 is smaller than 8. It would be right here. I would look at this one. And now if I look, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. That does work out. That's what we want to pick. Again, the reason here would be since 3 times, it's kind of weird that it's another 3, so I'll use a different color. 3 times 3 equals 9. Again, if we were actually solving this, we would take this one and we could multiply it by, I would say, -3. But 3 would be fair. You could subtract it after multiplying by 3. Integer or -3 is also an integer, so that's fine too. So that's why we would do it, because when we do this, we would get -9 and it would easily cancel out. So that's why we would pick B. For number 11, which one is equivalent to the system shown below? So it'd be equivalent. Again, that's where we're choosing a number to multiply everything by. So this one's kind of tricky just to figure out what we're supposed to do here. So with part A, so the first one we see is 10x. That would be 5x times 2 is 10x. 2y times 2 is 4y. 7 times 2, little time signs here, is 14. So that equation works out. 5 times 2 is 10. 2 times 2 is 4. But 7 times 1 is 7. So that one will not work out. So we can't pick C because this top equation doesn't work. Over here, I've got 5 times -3 is -15. 2 times -3 is -6. 7 times -3 is -21. So that's good. If we didn't want to do it with the multiplication, we could always divide. -15 divided by 5 is -3. -6 divided by 2 is -3. -21 divided by 7 is -3. So this one actually also works out too. So this is kind of weird because we have 3 of them that work out. So we have to check out the second equations. So for this one, for part A, 20. So to get from 2 to 20, 2 times 10 is 20. -4 times 10 is -40. But 3 times 1 is 3. So that one, we're not multiplying by all the same numbers, so that doesn't work out. It's not equivalent. We'll check out part B. 2 times 2 is 4. So far, so good. -4 times 2 is -8. Still so far, so good. 3 times 2 is 6. That one worked out, so we're picking B. I don't really need to check D since it doesn't ask for more than 1. I know D can't be right, but since we did the division for the top, we'll do the division for the bottom as well. 4 divided by 2 is 2. 8 divided by -4 is -2, and right away I see I don't have the same numbers, so that one's out. So that one doesn't work because the bottom equation doesn't work. That's what we got for number 11. So again, we're just thinking about which of those could be those integer multiples. thinking about being able to eliminate things. In this case, they didn't do a very good job because they didn't have anything that we could eliminate, but that's kind of the idea. All right, for 12, it says, as a first step in solving the problem shown, Noriko multiplies both sides of the equation 3x plus 5y equals 4 by 2. So she's going to take 3x plus 5y equals 4, and she's going to multiply that by 2. So that's going to give her 6x plus 10y equals 8. By what factor could she multiply both sides of the other equation so she could add the equations and eliminate a variable? So I have to think what number I would put out front here to make it so I could eliminate a variable. Well, since we picked 2, it would make sense to take the top number, switch the sign, and pick -3. Because when we do that, we get -6x plus 9y equals 21. And the whole idea is that this 6 and this -6 will now cancel out. So that's it, and the answer is -3. It's not asking us to solve it, it just wants to know what number we could multiply. Now our other option would be to multiply this -3 by something to get rid of the 10. But again, if we think about our multiples of 3, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. That probably would be the worst choice, but we could pick a 3.5 in order to make those two cancel out. Sorry, not 3.5, 3 1/3 in order to make those cancel out. But again, I don't think we would really want to work with the fractions. But 3 1/3 is also a correct choice. If you really wanted to do 3 1/3, that would also work because again, that would be changing this into a -10. Again, wouldn't really pick it. I don't expect anybody to really go for that one, but it is a choice. It is an option you could pick. All right, I think we're at the end. 13 is the last one, right? Yep. So Phil buys 3 pounds of grapefruit and 4 pounds of oranges for $14.10. Sandra buys 6 pounds of grapefruit and 3 pounds of oranges for $18.45. Let X represent the price per pound for grapefruit, Y represent the price per pound for oranges. So this is already set up a lot like the bracelet one that we had before. So we're going to get 3 pounds of grapefruit and 4 pounds of oranges for $14.10. So 3X plus 4Y, because it already tells us X has to be grapefruit, Y has to be oranges, is $14.10. All right, for the other one, where did the first part go? Oh, Sandra buys 6 pounds of grapefruit, 3 pounds of oranges, so 6x plus 3y equals 1845. So part A is done, just says write the system of equations. So that's it. B asks, what's the price per pound for oranges? So if we want, again, we have any method at our disposal. We're told that y is the oranges, so we're trying to find out what y equals in this question. So if you know that, you could just graph it and grab the y coordinate. The way this is set up, it's designed for a nice, easy elimination. So if we wanted to do elimination, 3x plus 4y is 1410. I'm just going to rewrite it down here real quick. Because this top one, if we notice, we can multiply this one by -2. If we distribute that -2, we get -6x minus 8y equals -$28.20. The bottom is 6x plus 3y equals 18.45. And now when we add these up, we can see those are just going to cancel out very nicely. So -5y equals, so that's close to $10, but not quite. So we're, 25 cents short. So that's going to be 9.75 negative. Is that the right way? That looks like the right direction. So we can divide both sides by -5. And again, we can see this is going to come out nice in terms of money. We are going to get a decimal. So let's see, this is going to be 1. And we're going to have, let's just do the long division up here. So 47 will get 9. 47 minus 45 is 2, so we get 5 for 25, so 1.95. All right, so that's what my answer is. Again, I felt a little bit shaky. I might have did my subtraction a little bit too fast. So just to double check, I'm going to go ahead and make a graph. So 3x plus 4y is 1410. And then for the other equation, we got 6x plus 3y equals 18.45. All right, I mean, my graph looks kind of weird just because I still have it all set to the other question that we did. And yeah, we can see we do get the same answer for y. If you really want to know how much the grapefruit were, they were $2.10. Didn't ask for it, which is why the graph might not be your best choice. Because we only need one, and it's the variable we get after we eliminate. So elimination was pretty quick. If we really wanted to double check, again, we can just double check it with the graph. So that looks good. Yep, 1.95 check. All right, and that's everything. So that's the entire study guide.